The battery suddenly runs out of power, and the device suddenly shuts down. Today, we only use these dozen common components to build a talking battery monitor. Green flashing means health, red light on means charging, no need for screen, it's easy to understand. This is the heart of the system, the NE555 timer. We connect it to a non-stable oscillation mode. As long as the fourth pin, the reset pin, is high, it will continuously output pulses to drive the indicator light behind. Then solder the green LED. It is directly controlled by the 555 output. It only does one thing: when the battery voltage is up, it flashes. It tells you everything is normal, but don't connect it backwards. To protect the green LED from being overcurrent burned, we need to connect a 1000 ohm current limiting resistor. This is a basic habit in electronic production. Each indicator light must be equipped with a suitable bodyguard. This 1 microfarad capacitor is the metronome of the entire flashing rhythm. Together with the two resistors behind, determine whether the green LED flashes fast or slow. A 1 microfarad capacitor with a suitable resistor just gives a striking frequency of 2 to 3 times per second. This is a 200,000 ohm resistor, is responsible for extending the charging time of capacitor. It makes the bright phase of the flash not too short, which makes it more comfortable for the eyes and more power efficient. Then comes the 22,000 ohm resistor. It works with the 200 kilo ohm resistor, one long and one short, ensuring the LED's flashing cycle remains stable. 2 resistors and 1 microfarad capacitor forms a classic 555 unsteady oscillator. A small 0.01 microfarad capacitor which looks inconspicuous, but it is a guard against interference. It is connected between the 5th pin and ground of 555. It filters out high-frequency noise in the power supply, ensuring the oscillation waveform is clean and won't flicker. Now, let's introduce the first voltage sentinel, BC547MPN transistor. Its task is to monitor the battery voltage. Once the voltage falls below the threshold you set, it will immediately conduct to the back. It will send a signal of low battery. This is the warning red light. The red LED does not rely on the 555 chip, but is independently driven by another transistor. Once the battery voltage is low, it will stay on. It will remind you to charge without hesitation. The red LED also needs current limiting. This 2.27 ohm resistor ensures moderate red light and prevent excessive current from damaging the transistor or LED. The second BC547 transistor forms a voltage detection team with the first one. It works with the potentiometer to accurately determine whether the battery voltage is below the preset point. Together, the two transistors to form an intelligent electronic switch. This 33,000 ohm resistor is the pull-up resistor of the detection circuit. It provides the transistor with the right bias to stabilize and prevent voltage drift. This is the setting knob for the entire circuit, 47,000 ohm potentiometer. Whether you want to alarm at 11.5 volts or 12 volts, gently turn it, you can precisely set the low voltage threshold. A screwdriver can be adapted to different battery systems. Finally, this 33,000 ohm resistor is symmetrical forms of voltage divider network. Together with the potentiometer and transistor, ensures that low voltage detection does not miss or false alarm. All components are soldered. Now connect a 12-volt battery. Rotate the potentiometer, set the threshold. When the voltage is higher than the threshold, the green LED keeps flashing. When we lower the voltage, the green light goes out instantly, and the red LED lights up steadily. The two states are clear and unmistakable. Without confusion, this is the reliability of pure analog circuits. Make one by yourself, and let your battery speak for itself.